Okay, so you've seen a magic trick. You've gotten to play with a couple of different Mr. Potato Heads. Can somebody explain to me one strategy that your group used to determine all of the different pairings? Yes. So you counted each of the body parts and you categorized and how many in those categories, okay? Did somebody do a different approach? Yes. Okay, what formula? What did you do? So you just squared the number of body parts. You made a formula, squared the number of body parts, okay? What are some other approaches? Yep. You just guess, okay? All right. What else? I saw some other strategies out there. Yep. Okay, so you just basically kept putting pieces of outfits together and then tallying as you made up a new outfit? Any other approach? I saw some group counting up total number of body parts. What did you do with that? Like total number of parts that were in the box. What did you do with that? You did what? You took the number of parts and you put it exponentially to the fourth. Why did you pick fourth? It sounded the coolest. All right. I will tell you that in the last, did you have another response? Okay, that's another good one. You counted how many little holes that the potato had, okay? So we're going to talk about those. In the last class, some people made some factor trees. You might remember that when you studied probability. I'm going to go and we're going to look at the spider spud. So, spider spud. I'm going to look at the first, okay? The first strategy I heard you guys talk about is actually the fundamental counting principle. So we're going to start with feet. And this particular one has two options for feet. So I would have feet, and I would have two because there's two options for feet. Now this is going with the guidelines that it has to have feet, okay? All right, so then next we have to have arms. And this particular one has two options for arms. So arms, two. And then this particular one has four different head choices. So four heads, and then it has a spider web that it can go with or go without. So that is two, with, without. Accessory, two. And we would multiply this together. That is the fundamental counting principle. You take the options for each category and you multiply it together. So in this case, 4 times 4 is 16 times 2. There were 32 outfits. Okay? All right. Another strategy. Another strategy goes with factorial. It also will go with permutations, which we're going to talk about today. And I heard somebody say they looked at the spud and they counted how many openings it has. So this one has 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay? The total number of parts are 1, 2, 3, 4, 5, 6, 7, 8. There are 9 pieces. So I pick one accessory and I take it out. So instead of having 9, now I have 8, and then I have 7, 6, and 5. Using this, we end up with 30 times 7 is 210. 210 times 72 is 0, 2, 4, 20, 0. I know. 0, 7, 14. So we end up with 0, 2, 1. Oh, sorry. 15,120 if I did my multiplication right. Okay? All right. We're going to study these two today. We will study combinations tomorrow. I'm going to give you a note sheet for us to look at. Okay, sorry, I wasn't very clear. In this scenario, we're saying that order does not matter. That's what's special about permutations. We are saying that the feet could be where the hole for the head is and stuff like that. And so that's why we got all of these extra additional combinations, okay, or permutations. Arrangements, configurations. I'm trying to avoid using the math terminology so I don't confuse and misuse those. All right. Okay, we're going to start with the fundamental counting principle. And we have an example. For a college interview, Robert has to choose what to wear from the following. Okay? So, he can pick from 4 slacks and then 3 shirts, 2 shoes, and 5 ties. So how many different outfits could he make? Okay, so we have 12 times 10, which is 120. All right, are we good? All right, let's look at another fundamental accounting principle. We are going to look at the Texas license plate. The Texas license plate has a letter, then it is followed by 2 digits, and then 3 letters. And they're saying that the letters and digits can be repeated. So if there's an A, there can be more than one A on the license plate. Everyone follow? In the English language, how many letters are in the alphabet? 26. Now, this one gets everybody. How many digits? There are 10. Remember, 0 counts. 1 through 9 and 0 makes 10. And we're saying they can repeat, so another 10 times 26, 26, 26. So either using your phone or a calculator, please multiply those numbers together and tell me how many different combinations of Texas license plate are there? Okay, I know this is not proper math, but it's easier for me to record it. Can somebody read the digits to me? 4, 5, 6, 9, 7, 6, 0, 0. So that is 45,697,600. Yes? Okay, let's change it up. Now, first of all, there's actually more than that. Because if you think about it, here in the state of Maryland, you also have different backgrounds. You have the War of 1812. You have the Shield. You have Save the Bay. So some states have multiple backgrounds, okay? They could. They could allow that. Then you have alumni tags and different things like that. All right, so we're going to change this, however. Texas now says that once you use a letter on the tag, you can't use it again. So the first position will still be 26 times 10 times 9 times 25, 24 times 23. How many combinations does that get me? Okay, say it to me. 3, 2, 2. Hold on. 3, 2, 2, 9. All right, so 3,229,000. Oh, there's one more zero? Okay. So that changes it. So it is 32,292,000, yes? Okay. Now we're going to talk about permutations. Permutations, the order matters, okay? And permutations, you're given extra detail. So think of it this way. I could say that we're running a race in this class, and I'm going to give a gold medal, a silver medal, and a bronze medal. In that case, the order matters. I could have also said instead I'm just going to pick the 3 fastest, and they all each get a prize. That would be combination. If who finishes where matters, that is permutation. If the order does not matter, that is combination. So let's look at my friends Jack, Bob, and Alice. And they're going to line up for class, okay? So one order would be Jack, Bob, and then Alice. I could go Jack, Alice, Bob, right? I could go Alice, Jack, Bob. You get the idea, correct? Okay. So we're going to first do the order by doing the fundamental counting principle. And to be honest, most of the time with permutations, that's what I use. I don't go into the full factorial. Okay? In this case, I have 3 spots. How many kids do I have to pick from? And now how many? 2, because once I pick who's standing first in line, I have 2 people to pick from left, and 1. Okay? So that is 6 different arrangements of these students. Okay? This would also be known as 3 factorial. 3 factorial. Factorial is when you have a starting number and you work all the way down to 1. Please note that 0 factorial is 1. Similar to any number to the 0 power is 1. Same thing. Okay? Because we always have 1 at the end. Factorial is all the digits and then 1. Questions? Yes. Would. How many permutations? Yes. The number of permutations is 6. And we use the fundamental counting principle to do it. Okay? Now, we're going to figure out the number of permutations, okay, for doing A, B, C, D. Okay? So, I have A, B, C, D. How many letters do I have? So I'm going to make a 4-letter arrangement. How many letters can I pick from? 4. I chose the letter C. How many letters now? 3. I chose A. How many? I chose D. How many? 1. Notice, I began with 4, and I worked all the way down to 1. So this is 4 factorial. And this happens to be 4 times 3 is 12, times 2 is 24. Okay? Factorial is when you take the number and you keep decreasing it. We are going to look at the following factorials, please. 4 factorial. Okay, Gideon, what number am I going to start with if it's 4 factorial? 4 times 1, which equals 24. Okay? If you will notice, there are 3 additional examples. Would you please work on those now, and we will go over those. Okay, let's look at the next example. 3 factorial is 3 times 2 times 1, which equals 6. Okay, the next one is 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, which is 30 times 24, which is 720. Last one. Now, I personally write out the last one before I do the work. So what is 5 factorial? 5, 4, 3, 2, 1. And underneath I should have 3, 2, 1. Now watch what I do. If it's in the numerator and the denominator, it cancels. So I'm left with 5 times 4, which is 20. And that's where we're going to stop the lesson today. Okay, so picking up where we left off yesterday, the problem says a television news director has 8 news stories to present on the evening news. How many different news stories can be presented? So that is going to be 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Can someone tell me how many options they have? Take out your calculators and test it, please. Okay, what did you get? 40,520? 320, sorry, thank you. Okay, good job. All right, now let's change the story, okay? Um, I'm going to use a combination of factorial and the counting principle, fundamental counting principle. I typically use the fundamental counting principle, and I do not use the full permutation formula, and I'm going to show you both ways, and then you can decide when we're done this section which way you would prefer, okay? So, 3 news stories. I personally would draw 3 lines on my paper. 1, 2, 3. So the broadcaster comes in, he's flipping through the script. At the beginning, how many can he pick from? How many choices does he have? How many choices does he have? 8. He has 8 choices. He picks one of the stories. How many? 7. All right, he picks another story. How many left to choose from? 6. So now, how many options does he have? What's 8 times 7 times 6? 1,300? Oh, sorry, 336, okay? 336, okay? So, this is solving the problem using the fundamental counting principle. I'm going to show you the permutation formula and show you how they both work. So, the permutation formula is going to be 8 factorial because we have 8 choices, right? Divided by 8 minus, we only have 3 slots, factorial. So that is equal to 8 factorial over 5 factorial, because 8 minus 3 is 5. So when I write it out, remember to write it out before you do the math so your math is left. 8, 7, 6, 5, 4, 3, 2, 1. I'm not going to show, they're all multiplication. And then 5, 4, 3, 2, 1. What cancels? Yep, 5, 4, 3, 2, 1. So I'm left with 8 times 7 times 6, which is the same answer I got from the fundamental counting principle way. Yes? Okay. All right, let me give you a moment to copy that down if you haven't. Okay, are we good? All right. Now I'm going to go on and explain the notation. And for today, you're going to calculate by hand. But tomorrow and in the future, I'm going to show you there are buttons in the graphing calculator that will calculate all this for you. But I think it's important that you understand the math behind it first. Okay? So I have 5P3. P stands for permutation. Okay? 5 is choices, how many choices you have. And 3 is the slot, like positions to fill. Okay? Using the fundamental counting principle, using the permutation formula, which is given to you, it would be 5 factorial over 5 minus 3 factorial. Okay? This is using the formula. I'm going to show you both ways, and I don't care which way you use. Okay? All right, so using this would give me 5, 4, 3, 2, 1 on the top. I'm just not making the multiplication mark. And on the bottom, this is going to be 2 factorial, so 2 times 1. The 2 and the 1 cancels. 5 times 4 is 20, times 3 is 60. So the answer to this is 60. That is using the permutation formula. But you can also use the fundamental counting principle, which is what I use because I think it's faster and easier. But that's just a personal preference, okay? So what I would do is I would notice I have 3 slots. So I would draw 3 lines on my paper. My number of choices is 5. Once you pick something, you have 4 choices and then 3 choices. Well, that's what I was left with in the numerator anyhow, and I still get 60. Okay? So now There are 4 problems below that, and you can either use the permutation formula or the adapted fundamental counting principle way to solve those 4 problems. I'll give you a couple minutes to do that and we'll go over the answers. Okay, let's go ahead and reveal the answers. So we had 4P4, 1, 2, 3, 4 slots. 4 times 3 times 2 times 1 is 24. The next problem was 4P1. How many slots do I have? 1 slot. How many choices? 4, which also is my answer. Okay, now it's going to get bigger numbers. Here we go. 8P5. 1, 2, 3, 4, 5 slots. 8, 7, 6, 5, 4. 120 times 56 is how much? What is it? 6, 720? Okay. All right, moving on. Last one is 12P7. 1, 2, 3, 4, 5, 6, 7. I'll squeeze it there. 12, 11, 10, 9, 8, 7, 6. When I multiply all that together, I get a whopping, okay, 3,991,680. Did I do it right? Good? Okay, so let's look at some word problems. By the way, a combination lock is a joke because it shouldn't be called a combination lock. It should be called a permutation lock because the order in which you enter the numbers matters. Something to ponder and think about. All right, so I have a combination lock. How many digits is the lock? No, three digits. Okay. If the numbers cannot repeat, how many numbers can I choose from at the beginning? 30, 29, 28. Multiply that together. Tell me how many combinations the lock has. Whoa, whoa. Say it again slowly. Thank you. I'm going to put you in. Okay, good? All right. Now, I have a club with 24 members. I need to pick a president, a vice president, a secretary, a treasurer, a historian. I don't know if you guys have historians, but when I was in high school, they had it and they took photos and stuff for that time capsule. All right, so, shh. Okay. How many people can I pick for president? Then, and please do the math for me. 5,000,000, 100,000, 100,000, 5,000,000, 100,000, 480. No? Whoa, I'm getting big, huge. Okay, hold on. There's argument. Let's type it in our. Okay. All right, so now that we figured that out, that somebody hit 20 twice, we're good to go. All right. Moving on. We're going to talk about combinations, and this is very important. Okay? Permutations are when there's more details. It's more specific. For instance, I could take this class and say we're going to go outside, we're going to run a race. I'm going to give a gold, a silver, and a bronze, right? So it matters who comes in first, second, or third. That's permutation. Or I could say we're all going to go out and have a race, and the first 3 people that finish get a prize. Does it matter in which order they finish? No, the order doesn't matter. It's combination. Okay? Good? That's why a combination lock is really a permutation lock. Okay. So we're going to take a deck of cards, 52, and we're going to say order doesn't matter, and I'm going to pick 5 cards. Anyone know what game I'm playing? I'm playing 5-card draw poker. Here we go. How many cards can I pick from? 52, 51, 48. So please, how many permutations are there? Okay, so we have 311,875,200. Thank you. All right. Now we're going to say order doesn't matter, okay? But we're going to reject duplicate, okay? Which means if it goes king 9 7 5 4 or 5 4 7 king queen, those are the same, right? It's just in a different order. So we want to get rid of duplicates. So we have to take this number, and because there's 5 slots, we're going to divide it by 5 factorial, which is 5 4 3 2 1, which happens to be 120. So I want you to take this 311 million and I want you to divide it by 120 and then tell me how many arrangements we have. How many arrangements? And I'm going to throw it back because Anna does a nice job of reading the number. So we're going to let her do it. Are we good? Okay, what you got for me, hon? 2,598,960. Can I get somebody to agree with that? Okay, so with combinations, we throw out duplicates, and I'm going to explain that in better detail in a moment. So there's 5 slots, so 5 factorial will handle all the duplicates. So 5 factorial is 120. So we took the 311 million, divided it by 120, and got 2 million. Okay? Can someone tell me why there's so many less combinations than permutations? Because the duplicates are eliminated, okay? If order does not matter, we're going to use combination. Now, I need you to take a timeout. You're not going to write anything. You're going to listen so I can put this into play so you can see why we throw out duplicates, okay? All right. You are in English class. 1, 2, 3, 4, 5, 6. The teacher presents you with 6 essay questions and says that you only need to pick 4 of them. So you might pick 1, 2, 3, 4. You might pick 1, 2, 3, 5. You might pick 1, 2, 3, 6, right? What happens if I pick 6, 2, 3, 1? Is that different from this choice here? From the choice? No. So that's why we throw out duplicates, because this one and this one is answering the same exact 4 questions. So combinations, we have to get rid of duplicates, okay? Okay? Did that make sense? All right, why we're doing this, let's go ahead, and I'm going to explain the combination formula in a second, but there's a word problem at the bottom of your page, example, and it's just exactly what I said, 4 out of 6, okay? So in this situation, does order matter? No, because you're I'll be honest, if I'm sitting in the English class taking the test, I'm going to scan through and go, number 5's easy. Let me do that one real quick. Oh, number 3. So it doesn't matter which one I do first, right? Okay, so order does not matter, so put no there for that question. So what is the combination? So to write combination is the same as permutation. How many items can I choose from? How many do I need to choose? So 6 choices, 4 slots. What do you think goes here? C for combination. P for permutation, C for combinations. And like I said, today you're going to do it by hand, and then tomorrow I'll show you how to do it in the calculator. Okay, are we good? Okay, so the formula for combinations, and it is on the middle of your page, is simply, we're going to do 6. Remember, I write it out and cancel out before I do the math. 6 factorial, which is 6, 5, 4, 3, 2, 1, over 4 factorial, which is 4, 3, 2, 1, and then times the 6 minus 4, which is 2. So 2 factorial, which is 2 times 1. Okay? If you notice, all of that is given to you in the formula. So it is the choice factorial over the slot factorial times the choice minus the slot factorial. 6 minus 4 is 2. Now I'm going to come through and cancel out